This is a short video about how to write the equation of a line in vector form using the vector product. It's a bit of a daft and a contrived way of writing the equation of a line, in my opinion. I think it's just there to give the examiner a little bit more flexibility in how to set vector product questions. The A and the B in this format mean exactly the same as they did in this format, which you will be familiar with from earlier work, where A is any specific point on the line and B is the direction vector of the line. Okay, so they mean the same thing. R minus a point on the line cross with the direction of the line equals 0 will give you a point which is also on the line. It should be possible to explain that a little bit down here. Remember that if the dot product is 0, it means that lines are perpendicular. Well, if the cross product is 0, that means that lines are parallel. You should be able to confirm that to yourself by thinking, well, the other form of the cross product is mag A mag B times sine theta. So if the theta is 0, or 180, the sine theta will be 0. So the mag A mag B sine theta will also be 0. So the vector product will be 0. So the way to think of this is if I've got any old point here, the vector r minus a is going from A to R. That's what r minus a looks like. In other words, it's minus a, which would take me back to the origin, plus r, which would take me out to here. So this is the vector r minus a. If my point R is going to be on my line, then R minus A must be lying along the direction of my line, in which case R minus A cross B must be 0. If my point R was not on the line, R minus A would look like this, let's say. It would not be parallel to B, the direction of the line, so R minus A cross B would not equal 0. So that's what's going on.